All right, guys.
Oh, wait, what number we got now?
1.7. Scalar multiplication. So we stopped at scalar multiplication yesterday to give y'all time to work on 1.6 assignment because we don't have the graphing calculators turned on yet for the Chromebooks. We're working on that, and hopefully that will get turned on shortly so that y'all can download that and utilize it. But what we're starting to look at first here is scalar multiplication. We're scaling something. Because when we scale something, we're either going to make it bigger or we're going to make it smaller. Like with model cars, how they say it's a scale model, it's scaled down. It's made smaller. So when we talk about scalar multiplication, we're multiplying by a scalar factor. Okay. Now, let's just look at it here. So the first example we have with scalar multiplication, and really the main one that we have is this here. We have 2 times the matrix here, this 3 by 2. And when we scale it, we're scaling every single element by a factor of what? 2. So we're going to multiply everything by? So we'll have 2 times 3, 2 times negative 2, 2 times 1, 2 times 5, 2 times 2, and 2 times 0. Well, looking at this here, what is 2 times 3? 2 times negative 2 is negative 4. 2 times 1 is? Bless you. 2 times 5 would be 10. 2 times 2 is 4, and 2 times 0 is. And that's it. We have now scaled that matrix by a factor of 2. That's the answer. Very good. Any questions on this one here? So let's look at this one here. Now we could also combine these scalars and our addition and subtraction together. Now the first thing I would do is I would apply any scalars that we have and use those. So here we're going to multiply the first one by negative 3. So we do negative 3 times 5, negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. Now the scalar only applied to the first matrices, so we don't do anything to the second one because it's only being applied to the first one. Now I will put in an interesting side note that whenever we do these scalars, especially with the second one, if it is a negative scalar, go on and take the negative with it. Because when I pull the negative inside, the number out front of it is just going to be plus. Because if you notice, the number in front of the first one is now positive 1. So if we were subtracting something from it, the negative would go inside. Does that make sense? So negative 3 times 5 would be negative 15. Negative 3 times 0 is? 0. Negative 3 times negative 2 is positive 6. And negative 3 times 4 is negative 12. Now we just need to add the 2 together, yes? Well, we could do this and rewrite it back out and say negative 15 plus negative 1, 0 plus 7, 6 plus 3, and negative 12 plus 2, or really, negative 15 plus negative 1 is negative, 0 plus 7 is, 3 plus 6 is, and negative 12 plus 2 is negative. And that's it. That's all I have to do for this one here. Any questions on any of this here? We good with this here? Yes. Okay. Okay, so we feel good with this here? Do we need to see another example of doing these scalars with scalar multiplication or addition? We feel comfortable with this?
Actually, can I use the bathroom in like 5 minutes?
Sure. Oh, let's do it. Let's see here. Do y'all feel comfortable with these two? Okay, let's do, say, 9 seconds, 876, negative 462, 84, 698, negative 1024, 2, 898. No, you're. Minus 60 over 3. 9, 8, 1, negative 2, 1, negative 9, 0, 9, negative 2, 7, negative 1, 0, 8, 3, 0, 3. Let's say 3 over 127, 0, negative 4. No, you're good. No. Nine. Yeah, this needs to be a 9. What did we, because we used this yesterday as a graphing calculator, yes? What did we use it for, guys? Because we saw 3 variable systems, right? With using what? We turned them into?
Can I use that bathroom now?
Yes. Because we plugged them into the calculator using what? They were a certain type. We set them up as what specifically? A matrix. What is all these here? So really what we have is that I can go second matrix and over to edit and tell it that it is a 3 by 3. Well, that says 30. 30 by 3. 3 by 3 matrix. So I can go in there and say 876, negative 462, 84, 698, negative 1024, and then 2, 898, negative 2094, and then 478. So that's the first one. Second quit, second matrix. And I can go to matrix B and say 3 by 3. And say 981. Negative 201. Negative 909. Negative 27. Negative 108. 303. alpha y equals enter for 3 over 27, or it should be 3 over 127, 0, and negative 9. And we went over this the other day, being able to type these in, being able to type the matrices in. So I'm going to go second quit. Now, the problem that I wrote up there, alpha y equals enter, was negative 9 halves, because that was our scalar for the first matrix, yes? And I identified our first matrix as matrix A, yes? So we can go second matrix and hit enter. So now it's saying negative 9 halves times matrix A. And then we subtracted from it second y equals, second quit, alpha, if I'm over in the right spot, alpha y equals enter, another fraction, 127 over 3, and then we want second matrix. This time we have to go down one to select matrix B, but that's essentially the equation that I wrote up there on the board. Yes? Yep. And last but not least, we just have to hit enter, and it tells us this here is the answer. But we didn't have to calculate a single thing, did we? No, we just plugged it all in. Yep. Now, the more that you kind of get used to using these calculators, you can actually blast through most of these, especially typing those matrices in. Because I think when you all were plugging them in the other day, once you did it a few times, it wasn't that bad to edit the matrix. So you get this here. Now, luckily we didn't get any fractions. I did that on purpose, because if you notice here, division of 2 for the first one, every single number in this matrix is divisible by 2. I chose that. And I made sure that the second one was all divisible by 3. How do we know if a number is divisible by 3? Guys? How do we know if a number is divisible by 3? If, besides the 3 over 127, if the sum of the digits is divisible by 3, then the number itself is divisible by 3. So the first one, 981, well, 9 plus 8 is 17, plus 1 is 18. 18 is divisible by 3, yes? So is it. Negative 201, well, 2 plus 0 plus 1 is 3, so it's divisible by 3. So when I was writing up those up there, I was just making sure each one was divisible by 3. But that's beside the point. So what I'm trying to show is this here. No matter how complicated it gets, the calculator can do it. Especially on the ACT, if it has you doing multiple multiplications, scalars, and addition and subtraction. You can do it by hand, but it might be a little bit easier just type it in and let the calculator figure it out. Because especially if it gets above a 3 by 3, I don't think they'll go higher than that. But especially with fractional scalars, it might be easier just type it in and have the calculator figure it out, especially on the ACT. Now, just in case we don't get there, we can also do matrix multiplication. That may or may not show up on the ACT. Now, we're not going to cover at this point here, guys, but if we go second matrix A, second matrix B, the calculator understands with those two next to each other like that, it's multiplying them together. And we can just say enter, and it'll go on and multiply the two together. We don't have to do anything with it. Now, the reason it's giving us a decimal is because of the 3 over 127. And it'll do multiplication for us. Second matrix. If it has to find the determinant of the following matrix, DET, under math, we'll do determinant. So it'll tell us what the determinant of the matrix is, and it'll give us a number, and we can figure it out. It'll tell us. So if we don't get to that by the next ACT, or the first one that y'all take, the actual ACT, the calculator will do most of these and all these matrix operations for us. Yes, sir.
So, I don't know if I am not, but I'm just wondering for the people that aren't. Say you are not going to college, but you know for sure you don't want to go to ACT. You just gotta take this.
The ACT is the end of course that you have to take it for here by the state it's required. But I would suggest taking it anyways and trying your best on it because, I mean, if for some reason down the road you wanted to go or changed your mind and wanted to go to college, you can still get those scores. It's not pretty much within a certain amount of time they throw them out. Because I took mine in 2010, I think was the last time I took the ACT. If I wanted to, I can actually pretty much contact ACT and actually get them to pull my scores. So if I needed to, if I didn't go to college and wanted to go now 10 years later, they can still pull those for me, and then I can apply with those scores to the different universities. So even if you're not planning on doing those, is still good just in case. I think my composite was around a 25. So the English was the one that was always my lowest score. Yeah, my math was the higher one. I think it was around the 25, 26 or higher. I can't remember. It's been too long. And I'm not going to pay to pull them because after a certain amount of time, they charge you a processing fee. If it's after 10, 5, 6 years per test that you took. And I think I calculated up last time was like around $100 to get my scores because it's past that window and I have to pay a processing fee for each of the 6 ones that I took, which is non-refundable. If for some reason can't find it, I still have out that plus the cost per each test. So it's still, it's around $80 or so for the test, but the school board did approve. So the one that you'll take in the fall, and I think y'all took one last year, that was paid for by the school. The one that y'all are going to take here in the fall is paid for by the school, and the one in the spring. The one in the spring does, but not the one in the fall, because the one in the spring, what it does is it gives us a letter grade for how well each subject's doing and overall how well the teachers are teaching and y'all are understanding. So the better that we do there, the better overall the funding and everything else becomes. Somewhat. But it can also go the other direction, and it's also not great because if they don't do well, I mean, obviously it's y'all's doing it, but it always comes back to us because I think the first year they started the ACT, or the first year we got the scores back, me and Miss Kendall actually had to have a sit-down conversation with Miss Shackelford to explain why the ACT math got a grand total of 0 points towards our letter grade. So, yep. So, there is that. I'll talk. Oh, here's the assignment. I'll talk about that here.